Along with constructing that line of best fit, we can also look at calculating what's referred to as the correlation coefficient, which is represented as a lowercase r, and is a value between -1 and 1. That is, our value r is greater than or equal to greater than or equal to -1, less than or equal to +1. A value close to 1 would imply a strong positive association. A value close to -1 would still imply a strong association, but in this case, a negative association. So our values of +1 and -1 are both associated with a strong relationship, but what changes depending on the sign of our value for r is whether that relationship is positive or negative. And then values that are in the middle, close to 0, imply little to no association. And then there are values in between -1 and 0, and 0 and 1, where there's some more ambiguity, but a later topic will help us get into that a little bit more in depth. Let's revisit the graphs that we already considered in the first 3 examples, but now we'll take a look at the correlation coefficients for those to see how that would correspond. In the first example, where we're looking at faculty and students, the slope of that linear equation was 18.4574, which obviously is greater than 0. The correlation coefficient, once we learn how to calculate that, would come out to be 0.9462, which is very close to 1 and would indicate a strong positive association. So our value for r in this case is greater than 0, just like our slope, but also what's important is to recognize that it's very close to 1. We could have a positive value for r and have it be closer to 0, which would suggest little to no association. In example 5, we were looking at the number of school enrollments versus the number of people living below the poverty level, and our slope in this case was -0.04787. That value is less than 0, and our value for r in this case would be -0.9037, which is also less than 0, but also a value that's very close to -1. So we would classify these two data sets, as having a strong negative association. So really we're classifying 2 variables in the type of association that exists, something that we've done with scatter plots already. We've seen how the slope of our linear equation for that line of best fit can correspond to that, but the value for r, the correlation coefficient, reduces that concept or that question down to a single numerical value and helps us with classifying the strength of that type of association. And then in example 6, where we have data on the number of ghost and UFO sightings in different regions, we would have had a slope of -0.0993, which is close to 0. And we would have a correlation coefficient of -0.0991, which is also pretty close to 0. If the correlation coefficient is close to 0, that suggests little to no association.